Recording. Okay, so welcome back, everyone. I hope everybody is doing well. I see a couple of students missing, but that's okay. Um, okay, so what I'm going to do, as usual, is make a couple of quick announcements and then jump into um, the course material. So the announcements are about the timeline. So today is 19th. So today we'll be looking at finishing up Docker, and hopefully we'll also use one of the managed solutions for dealing with Docker or containers, which is called ECS, Elastic Container Service, by AWS. So once we do that, what we'll do is skip the next chapter, although the next chapter is talking about a different way to manage containers using a technology called Kubernetes. We'll skip that chapter for now. And hopefully in today's session we're going to talk about scheduling jobs, and in particular ML pipelines, and how do you periodically run training and periodically run model updates and so things like that, or prediction updates and so on. And when we do that, we'll pick back up the Kubernetes piece that we skipped. Okay, so which means that when we look at pipelines towards the end, we'll anyway use Docker again, and when we use Docker in one of the cloud services, we'll try to use Kubernetes. Okay, so I'll tell you what how it fits into the bigger picture as we go along today. So just recap, till last time we went through Docker's tutorial basically to get a sense of what is Docker, what are containers, and how do you build a container from scratch, basically. So build an image from scratch, and then how do you run that image, how do you run a container from that image. Okay, so that's the idea for today. Again, continuing on with respect to timeline, next week we'll possibly look at one of the topics that's left out, either PySpark, or basically large-scale data processing, or streaming data processing. Not just processing, this includes also deployment and making predictions and so on. And or we'll also look at the third topic, which is online experimentation, which is A/B testing. Okay, so one of these three topics we'll pick based on where we are today and what's the most useful topic to pick given what we know so far. Okay, so that's the idea. And after that, the third week from now, which is I guess, sorry, not third week, but 2 weeks from now, is the presentation of your individual exercises or projects or assignments. We just calling it projects, but basically your foray into trying out a technology for deployment or some aspect of machine learning lifecycle. Okay, so so that would be 2 weeks from now. And I think each team will basically have a very short demo or a presentation of what you've done, basically based on your submission that you would do the previous day. And there'll probably be a bunch of time left for us, and we'll pick up another topic from the three topics that I mentioned. Okay, which is PySpark or streaming or A/B testing. Okay, whichever, depending on how much we have covered in the next couple of weeks, today and next week, we'll pick up. We'll continue that topic. Okay, so
Hi, Professor. This is Laura. I just have a question about the
yeah.
final project. So you said we will be submitting a PowerPoint presentation to you the day before, right? So like
No, no,
March
no. So
3rd.
no PowerPoint presentation submission is needed. The
Oh, okay, okay.
submissions are just the submissions are the reports,
Oh, okay, okay.
for which the grading would be done for.
Oh, okay, okay, okay.
The slides and stuff, that's up to you. You can have a
Oh,
slide
okay.
deck. You can also not have a slide deck,
Oh,
whatever
okay,
works for you.
okay,
Uh, I'll just communicate what is the timeline. So I have an estimate of what's the time for each presentation. For
okay,
example, it's about 8 minutes. 8 minutes. Okay, just 8 minutes, which is quite
okay,
small, quite less. But that's just to ensure that everybody gets a chance and maybe ask a couple of questions if needed, and
okay,
also cover some of the topics that we are continuing to cover in
okay,
this course. Okay,
okay,
so yeah, the slide deck is totally up to you. And you can also do a demo. If you have a Heroku app or something on EC2 and you expose the port, you can clearly
okay,
show, hey, this is how my this is how I've deployed my model and stuff like that, right?
Okay. Okay.
So, yeah.
Okay. Thank you. I appreciate it.
Great question. So yeah, that's it for announcements. Basically, what are we going to do for the next 3 weeks? Sorry, next 2 weeks. I mean, excluding today. Today we're going to continue with Docker and ML pipelines or ML data science workflows in general. Next week, one of the topics between PySpark, streaming, and A/B testing. And the week after that is going to be presentations plus some leftover topic, based on how much we cover. Okay. So with that, let me switch over to yeah. So before I actually get into Docker and some details, most folks have gotten up to this point for sure, right? I mean, this is something where we rented a machine basically on somebody else's place, in this case, AWS, and we started a Jupyter server on that site within a screen session, so it's always running, and I just connected it by running one of those commands, right? So in my case, where is, yeah. So in my case, the command was something like this. Okay, so it's basically, hey, use the PM file and some extra fields. Actually, some of them are actually optional, including this. This is also optional, P22. You don't need this. And then your username at some IP. Okay, so this is the command I ran locally on a terminal to get at this port access to the Jupyter server running on the remote machine, okay, through the SSH protocol. So that's good. So there's actually um, um, a different program that you can also run. So I just want to show that before we get back to um, our topics. So let me open a terminal there. Okay. So here we are in base. So let's actually go back to the appropriate Conda environment. Conda activate. I actually don't remember now. And list. So I think is this one, data sci -38. Okay, so what I'm going to do is install a slightly different thing. So let me actually go to jupyter.org. Okay, and Jupyter.org is exactly the Jupyter Notebook stuff that we're doing. And there's a slightly different program called Jupyter Lab. Okay, some of you may find this more interesting, so I wanted to quickly show you. So let's install that. If you just click install, it'll just the first command. Let's install that here. Oh. And folks have already zeroed in on Jupyter Lab. That's great. So whichever one works, Jupyter Notebook and Jupyter Lab, they share some code base. They share, for example, if you already set a password, then the same password will work for Jupyter Lab. The Jupyter Lab interface, again, is in the browser, but it looks a little bit different. Maybe, more interesting to some of you. So let's see. Okay, so we ran this. Now, what do we, so now it's installed. Okay, so now let's go to screen. If I look at, so by the way, I think the font is unfortunately not good here, but I hope folks can see what I'm trying to do. I just did screen-list, screen space -list to get a sense of, hey, what is running? And we know that there's one, there is some screen session running. Okay, so that's actually, in fact, I do screen -R, I'll just reconnect and you'll see that, hey, this is exactly the type of prints that you'll see when you started a Jupyter server, right?
Professor, hi. Sorry, can you go back to what you actually installed? I just didn't get the word to look for that.
I just installed the same thing, Jupyter.
Oh, okay.
So I think we had installed Jupyter before. I just installed a slightly different thing called Jupyter Lab.
Oh, okay.
And the command to install, if you're using Conda, is this. If not, you can just use pip install.
Okay.
One of these commands. I could have run this command actually from one of the notebooks, but so we installed it. Now what I want to do is So create another screen session, screen minus s. Minus s just means the session name that I want to create. Let me call it lab. Okay, so it's something different. It's just for showing you that there's some slightly different web view or slightly different browser view that you can see. So screen minus s lab is just a new screen session that I'm creating with a name called lab. Okay, so that doesn't change much. It's just exactly the same thing. So again, I have to do, because I executed that command, I'm in now a terminal within a terminal. So again, I have to do conda activate data sci 38, and you can know always which environment you are in. So we are now here. So let's actually yeah, we are in some folder, I mean the root folder actually. Sorry, not root folder, but the home folder for the user. So let me just type Jupyter Lab now. So not Jupyter Notebook, no browser and stuff like that, but just Jupyter. um, oh, it's not Jupyter hyphen lab. Okay, and I'll also type no browser and press enter. Okay, it'll say, hey, it's running at 8889 because 888 port, already I'm running Jupyter, I'm already running this guy, right? So this guy was already from that, machine, I'm already running Jupyter Notebook or Jupyter Server, right? So that's why it's saying, hey, that port is, I guess, busy. So see, the port 888 is busy. So let's pick another port. It picked 8889. Okay, that's fine. So again, since it's a screen session, I can exit from the screen session by typing control plus A at the same time, and then D, control A, D. It says detached from that screen session called lab. Okay, there's some extra numbers in the front. It doesn't matter. It's a screen session which has the name lab. Okay. So we have started Jupyter server, Jupyter Lab as well. Okay. Now what we do is, again, let's use this command here. Um, and what we'll do is, instead of this 888 stuff, let's book 9000 as a local port. And on that machine, the remote machine where we just started Jupyter Lab, we know that it was running on port 8889. So we're just going to change this 8889. Okay. So this is a remote port. This is a local port. What I'm going to do is run this second command locally on my machine. So not on the remote machine stuff, not in the browser, but a terminal that I have, for example, in Mac or Linux or even Windows. Let me run this. And then I'm going to open localhost 9000. And all this exercise is just for you to see a slightly different interface. So let me now open localhost 9000. Okay. Actually, I don't know if this password works. Okay, let's see. Oh, it did not work. Okay. So, okay. So
I think we did TEST.
what's it? IDS 594, I believe, is the password, but it didn't work. That's fine. What I'll do is just edit the file. So okay, so the way if password doesn't work, then what you can do is you can do vim dot Jupyter, and you'll see that a couple of files there. Okay, there's a JSON file and there's a node, py file. This is a config file. Okay, it's literally a bunch of variable name and what value it should take, variable name, what value it should take, and so on. So what you can do is just see what the password config, if I do JSON, there'll be some password. Okay, if you can see that the password string is like a huge mess here. Um, it's encrypted, and that's why it's a huge mess. Okay, let me copy that, and then quit that opened notebook. Sorry, opened text file. Now I'm gonna edit. Okay, this is an extra step just because I couldn't log in there. Um, the py file. If I open the py file, actually um, the color coding is terrible here. But what I'm gonna do is what I'm gonna do is see that I'm gonna go to a location where it says enter the password, and I'll just paste the string that I got. Okay, notebook. Oops. Sorry, this is like even bad for me because I'm not able to see the colors. Okay, let me set the numbers first. Okay, what I'm gonna do is find it's not passwords, is it? Let me see. Yeah. So sorry, I was just searching for a wrong pattern. So the way you search for a pattern is put a slash. You can see I'm not in editing mode. So I've pressed escape. So you can see that there is no insert mode or something that shows at the bottom. I can do a slash. You can see at the bottom there's a slash. And then I can search for the string c dot notebook app dot password. Okay, it's on line 402. So okay, now I know which line to edit. So let me actually go to that line 402. Oops. Actually, going to the line, there's a command, but I'm not gonna. Okay. So if in case you don't log in, this is just a quick fix. Okay, so let me. I don't think I even have. Oh, I do have it. Okay, great. So that's great. So that's it. Then I think I hope this should work. Let's see. Oh, no. Let's. Okay, let's restart the thing. Okay, I think I have an issue with logging in. Okay, actually, you know what? Instead of me tinkering this, let me show you a local instance of the same thing running so that we have a. Yeah, so this is a local instance that I'm just running so that you can see how the interface looks like. So this is the interface. Okay, so sorry about the password issue, but it's the password thing is just exactly set the way I generally set it. So you just have to set the password beforehand. Otherwise, it'll ask for, hey, what's the authentication? Okay. And the setting of the password is exactly the same as the way you would do it for Jupyter setup that we did in first session. Okay, so let me not worry about why it didn't work now. But the interface would just look like this, okay, which basically is, Jupyter Lab interface, and Jupyter Notebook, the vanilla interface looks like this, bunch of files and you can open them. Here it's the same thing, bunch of files, but it looks like basically that you could do a little bit more, right? You can write, you can open terminal, text file, markdown file, things like that. And you can open anything here. Like I can open the syllabus page, and it's the same thing. It's editable notebooks, very similar to Jupyter Notebook. So there's not a big difference other except for this extra stuff. You'll have a extra, I guess, menu bar and so on. Okay, so quick info on that. So you can try offline instead of Jupyter server. So instead of starting a Jupyter server, you can start a Jupyter notebook, a Jupyter Lab server, and the interface will be slightly different. But it's it's exactly the same idea. You'll have a bunch of notebooks. You can edit the notebooks. There'll be kernels associated with each notebook, and you can actually click on things on the right side to get a feel for it. Okay. It's a little bit more featured than I would say the vanilla interface, but that's pretty much it. Any questions about this part?
Yeah, Professor. I'm not I don't have any questions about the lab part, but I had a question about how you found all the environments that you had on like your like the data site environments. I just didn't. Can you type the code for that one more time, just so I can see?
Environment. So did we do anything
Yeah.
about the environment
Yeah,
here?
like data site environment. We chose like data 38, data site environment 38.
Okay. How did I get that? Okay, so actually, let me. Sorry about the. Actually, can you guys see the font? It's terrible, right? So actually, let me open a notebook. Actually, we have ton of notebooks. Okay, let me open one more. Yeah, so I just typed conda n list. Okay, so I mean, since I'm typing it in here, I just put a dollar in the front.
Okay,
Sorry,
okay.
exclamation mark in the front. These are the environments I created. Okay, I created, what happened is I created this environment. It has Python 3.9, and then PyTorch was complaining that there's some incompatibility issues. So what I did is create another environment where I installed Python 3.8.
Okay.
That's the only difference between
Yeah.
these two.
So
And
I
I'm
don't.
just continuing to use 3.8, but it doesn't matter. You can just
Oh, okay. Can
use
I?
any
Would
environment.
it be okay if I just use the data site environment because I don't have any issues with that?
You can use any environment you want. That's
Oh, okay, okay. I was
totally up
just
to you.
curious.
You can define any environment, any name. You just need the environment is just to encapsulate your project. So if you're working, let's say you're a freelancer, you're working with two different people on the Python projects,
Oh,
and they have different versioning, different requirements, and so on. So you want to keep things separate, right?
Yeah. Okay, awesome. That's amazing. Yeah,
Yeah.
thank you. Appreciate it.
Okay, so okay, that was supposed to be very quick, but it was not. So that was Jupyter Lab. So let's now come back to where we were with Docker. So yeah, so I want to first again repeat what the lay of the land is, and then get into some details. So last time we were looking at chapter 3, looking at, hey, what's the advantages of advantages and disadvantages of container technologies. And there were many vendors who would let you think about containers or create images from which you can create containers and so on. Docker is one popular technology. Last time I also mentioned another one, which is called Podman. So these are different technologies run by different companies. I think Podman is by a company called Red Hat, I think. So there are different vendors, but basically the idea is containers don't have to have an extra layer of um, uh, when programs run, in the sense that extra layer is the guest operating system. So if you run a virtual machine, for example, if you install VirtualBox and then started a virtual machine, then you know that the virtual machine needs to have its own operating system. For example, if you're on a Windows machine, you install VirtualBox, you now also install Ubuntu or something else as a virtual machine, and then inside that you can run your programs. Okay, that's a lot of extra layers. Containers trade off certain things and let programs run without this extra virtualization step. So each container is basically a process, as like a .exe or a process in Linux or Mac OS. And within that process, there's your script, model training script or model deployment script. Generally, is just has a limited view. Okay, so it doesn't know what the full file system is. It doesn't know what the full event system resources are, like full RAM capacity and all that. It only knows the amount of information that's allowed to see. It's allowed to see. Okay, and so that's the level of control that you can have through the idea of containers, and that control is also defined in that image that we create, okay, from which the container is spun out, right? So last time we saw what's the difference between containers and virtual machines a little bit, and then we created a few containers actually. The key part was to use this Docker file, which would start with some base image. Okay, it could be some already pre-existing OS like Ubuntu or something. For example, last time we saw a node example as well, a node-based example. So it'll start with some pre-existing image and then add our extra commands like, hey, install A, B, and C dependencies, copy my files over, and whenever the container starts, start a command. Okay, command, let's say like Python execute my flask file.py or something like that, right? So that would be defined in a Docker file. It's just a bunch of, just a text file with a bunch of lines. And from that, you can create your custom images, okay? And what we did not cover last time yet is how to upload these images to a remote remote registry. It's the equivalent to a repository, basically. And one example of a repository is hub.docker.com, I think. Hub.docker.com is basically it's like GitHub, right? So you can actually explore and see who all have different organizations, for example, have images available. Okay, and you yourself, with your name, for example, instead of it could be your name here, and you can have your own images also publicly available for other people to download and run your container, for example, right? So so that this is a public repository, but what we want to do today, get started with, is, let's go back here, is to try out Amazon's Elastic Container Registry is a private repository, private in the sense that it's private to our organization or our company, where we can create that image and then use additional services, in particular a managed service that we'll use. It's called ECS, Elastic Container Service, to run our container on AWS. Okay. So last time, from the knowledge from last time, how to create an image, how to start a container, at that point, we can already do the hosted version, right? Which is, hey, rent a machine like EC2, just like we have done here, right? Just like we've done in the first session, second session, and so on. We always have a rented EC2 machine. On that, just install Docker and create our image and therefore start our container, and that's it. And then as long as the container is running, we can exactly query. We can if it's, for example, it's a web server, it's serving HTML pages. You can hit the public IP of your machine, and that will get rerouted to the containers port, whichever port it is, and you'll be able to see the web page. Okay, so at that point itself, we can just we are done with the flow, which is that we created an image from which we got a container. We can run the container on a rented machine like EC2 machine. But what we want to do today is to upload that image to a third party, in this case, not third party, to the cloud vendor, in this case, AWS, and then use that image in a managed service called ECS. Okay, instead of using that image in a machine that we spin up. Okay, let's say a T2, some PX large or whatever is names of the machines in AWS. Instead of us starting an EC2 machine and then starting a container, we will do it in a little bit hands-off way. And what's the advantage that we get is it's going to be a little bit more managed. Okay, so it's going to be closer to how serverless was, where we literally were only worried about the code. The underlying hardware, we did not even know what the hardware was. I mean, there were some specs there, but we were just worried about our files, right? The main.py, for example, and requirements.txt for the Google Cloud Function are equivalent for Lambda function, right? So we'll get a little bit closer to serverless technologies as managed service. Okay, so that's our initial step. And what we'll do is skip Kubernetes for now, because we'll actually touch Kubernetes again when we talk about model pipelines. Okay, and hopefully we'll try to cover at least a good chunk of, at least half of this chapter today. Okay, so any questions about the lay of the land? I'm going to discuss what entails, what are the key aspects in model pipelines when we get there. So I don't want to talk about goals now. I will come back to these goals when we finish up deploying an image on a managed service like ECS. Okay, if there are no questions, then what we'll do is first of all, what we did last time is only use the playground, the playground instance or the playground, I guess, virtual machine that was available to us through the docker.com to try out how to run containers, right? But today, because we want to use our AWS credentials, it's probably not advisable to use a public instance. So what we'll do is do some of the steps we did last time of creating and building an image. Of creating a Docker file and therefore building an image on our rented machine. Okay, it could be on a local machine, but we'll just do it on the machine that we have always had. So which is this machine. So for that, actually, folks, can you see this properly? Or can you see the terminal properly? Or
Yeah. Yeah.
I don't know if this helps. Okay. Okay. So what we'll do is first of all, we'll try to install Docker. Let's see if sudo apt install Docker works. If not, we'll have to look up instructions. What did it say? New packages will be installed. Docker. Okay, let's see if that's enough. And generally, packages, at least in Ubuntu-based, Ubuntu or Debian style system, it's just going to be sudo apt install if you know the package name. Typically, it's going to be straightforward like this. If not, you'll have to go to docker.com and see how to install it. So let's see. So the way you run, so we'll just quickly check whether Docker runs. So we'll do sudo docker run. So when we call a run command, you remember that we have to already have an image present. Okay, if we don't have an image, it'll download the image. It'll try to download the image from the hub.docker.com, which is a Docker remote repository. Okay, so by default, it'll just search for, hey, like for example, if I run docker slash hello world, then it says Docker not found. Okay, I have to install it this way. Okay. We'll just, so this is how we install Docker. So actually, what did I do here? I just ran this command, sudo apt install. Sudo is the sudo user, so you need to know the. Okay, actually the Ubuntu user is already in sudo, I think. So don't have to do anything there. Let's come back here. Okay. Yeah, that's all fine. So it's got installed. So to run, let's run a does not exist. Okay, so actually let's try Docker getting started, which is what we tried last time. So okay, so I ran a random, some arbitrary image. Okay, so what it did is, hey, this image is not present locally, so let me get it, and it got the image, and now it's trying to run it. I don't know if this works. Sorry, I was just trying to see how much resources are there in this machine. Downloaded image. Let's see. Yeah, top is a command which just tells you how much resources are being used. So it doesn't look like much resources are being used. So you can see 1% of CPU, 4% of memory is being used. So I don't know what's going on here. In the meantime, let's actually see sudo docker images. I mean, you'll see that the image is definitely present, but I think the run command is having some trouble. I don't know why. Let's try sudo docker run docker / getting started. So what does command mean? Sudo docker is generally what you would run in these, by default, just think of it as the default way to start, call the docker CLI command line utility. Run is the specific keyword, right, to run a container, and this is the name of the image, and the name of the image is literally written here. So I mean, if I have other images, it will be just extra. There'll be other names in this list when I ask for the list of images, and I can try them. Okay, so let's see what happens here. Somehow I am not able to run. Interesting. Is it I think there's some issue with running. So I can type sudo docker ps to see if okay. Actually, I sorry about that. I forgot that this is supposed to be run as a background, as a daemon. So so it did run. So in fact, where's this guy? So let me also cancel this. Okay. So what I need to do is now ps minus ps. Let's say there'll be okay ps. Okay, there's no containers running now. So what I was supposed to do was the following. Okay, sudo docker minus d. Minus d means run it and in the background. Okay, and then port, because it turns out that the getting started thing is actually just a bunch of HTML files. So we're just going to port forward to since we tried. Which port should we try? Okay, let's try. Let's use 9000. And 80 is the internal port, and then docker slash getting started. Okay. Oh, that was not correct. Oh, sudo docker run, and then the enter. And then what you get is a huge string. And if you get a huge string, that means you succeeded. And how do I know this? So we can again go back to docker space ps. PS just shows you what are the processes, what are the containers that are currently running or might have exited, and so on. So you can see that. Actually, let me try to. Oh, now I've lost. Yeah. So it says, hey, this is the container ID. This is the image from which I created the container. Some command was run, so let's not worry about the command because we just got it from Docker, the company. It was created some seconds ago, and it's at port 80. Okay, so actually this is okay. I think incorrect. So it should be actually, yeah. Okay, this is fine from 9000. So what we'll do is just to check that I gave the right ports. Let me run one more command, which is locally I want to view whatever was running at port 9000 on the remote machine. Okay, so I'll just run this locally. Okay, now let's go back here and try localhost 9001.
We're missing an S, professor, on that.
Good point. Host. Okay, yeah, so great point. Thank you, Shivani. So sorry, I've been hitting so many hiccups in the past few minutes that like, okay, what could be the error? Anyway, so basically what we did is basically run this. What we changed was we combined, of course, minus d minus p to just minus daemon mode and port. And then we just changed the port. Instead of 80, we just pick 9000. And we also did an extra thing, which is whatever was 9000 there, let's forward it to 9001 locally so that we can open that in the browser. And it turns out that getting started is just a bunch of HTML files. It'll say it's basically a tutorial. And this is exactly what we did in the playground VM that we got last time. Okay. Anyway, so if you don't remember, just go back to that recording that we have from last session. Okay, so that's good. Okay, so yeah, now actually let me come back to what we was trying to do. So okay, so now what we want to do is create our repository. So create our image, which is related to predictions. So in particular, we'll try to create a image which has the prediction model for recommendation system, right? And then we'll try to push it to AWS, one of the registry. It's very similar to hub.docker.com, which is going to be the AWS ECR. Okay, it's called Elastic Container Service. Sorry, Elastic Container Registry. To do so, we need to build the image. So let's do that. So let's see what are the notebooks we have. So very similar to a couple of sessions ago, where I said how to do this. So let's actually move the MLOps notebooks, MLOps notebooks to MLOps. I'll just give a 0 to 1, 2. I'll move that and then git clone from our repository. It's just, you don't have to do this, but just an easy way. Okay, so this is the link. Yeah. Oh, notebooks have changed. Okay. Let's do the same. Actually, let me go to MLOps. Code examples. Did I do anything? Oh, I did change a few things, so let me not worry about it. Okay. So I'm going to do the same thing what I did with the notebooks. I'm going to move the MLOps code examples to MLOps code examples from 0 to 12. And then run that git clone command that I just ran. Okay, so that I can get the latest bunch of files. So let me go to MLOps code examples. So here you'll see that I've done a little bit of rearrangement of the files in there. Previously, it used to be a bunch of files all at the same time. So Flask examples are all in the Flask directory. In fact, we can pick up the Flask a Flask script from Flask examples and create a Docker image or Docker image which uses that Flask thing. So there's also model to create the model pickle file, not pickle file, but equivalent to a pickle file. That's also there here. And Lambda function and Cloud function, if you want to try it out offline. We have seen this in previous sessions, but if you want to try it out, these are the example functions. Okay. So let's actually make directory called for Docker. Okay, and let's go to for Docker. And then let's copy from Flask examples Flask recommendation service to this folder. Okay, so what I did is just copy a Flask recommendation service file. So okay, so this file has this file needs a couple of extra things. So let me so what does this file need? So we can actually see the file, I believe, from here. So let me just go to code examples for Docker. Yeah, so you can see that this is literally a Flask file. It just needs the movie.dat and the recommendation model pytorch.pickle file. Okay, so with these two files, this Flask, I can literally run it directly in the in the command here, and again do port forwarding to be able to see whether it actually gives me recommendations or not. Right. So so what I'm trying to do now in the next couple of minutes is get the required files, the movies.dat, the recommendation model, and then I'll create a Docker file. Okay, using all of them, I'm gonna create an image. Okay, so let's get this extra files. So I'm trying to see if we already have these files, I believe. Let's go to home folder. There is a model file, but I don't see the, okay. So let's see, copy from tilde/dot surprise ml1m. So it turns out that when you run the, if you had run the training file, recollect the training file is just one of these. Let me click on this. The training files is just one of these files. Okay, model examples. We had this recommend PyTorch inf or recommend PyTorch train. If you just run that file, it will just create a it'll download the data, the movie lens data, which is this user item, some rating that the user gave for the item of the movie. That data will be available in this location. Okay, I'm just picking it from that location. It's called dot surprise data slash ML, just means movie lens hyphen 1 million. It's just again repeated folder name movies.dat. So I'm just going to copy that file here, and we just saw that the copy tilde slash recommendation pytosh dot recommendation model pytosh it's a pickle. I'll also copy that file. Okay, so we have those two files. Now what we need is also a slight change. Let's actually go back to Flask recommendation service that we opened. We'll slightly change it so that it doesn't get the file from somewhere else. It just reads it locally. Okay, locally in the sense of from the current directory. So dot slash file name means read it from the local directory. So let's do that and save it. So okay, so those two files are there. So if I run Flask app now locally, actually what is going on here? Let's not worry about that. So if I run, for example, Python Flask recommendation service, press enter. Oh, okay, I don't have, oh, we're running it in base. Okay, so sorry, I need to actually activate data psi 38. Okay, actually, if you don't want to run this command again and again, you can actually put it in, you can ensure that this command is run every time you open the terminal, but I'm not gonna do that tangent now. So let's run this. Oh, okay, it needs those extra files. Let me copy those files. Copy models. Recommend PyTorch star to here. Okay, again, I copied a couple of files. Okay, so what did I copy? I have this original Flask file. It just turns out that the Flask file needs some functions which are written in these other files. So I just, this other file called train.py and inf.py. Inf means just inference. Okay, so anyway, there's a couple of functions there that I wanted to use instead of copy pasting the same functions in multiple files. I just kept the functions at the same place and then just importing them. So now if I run Flask, it should run. And now I can also port forward yeah. So if you look at the Flask file, first what it does is tries to load the movie file and the recommendation file. That itself will take some time. After that, it starts serving requests. Okay, so you can, let's wait and see how long it takes for this guy to do this. Should not take too much time. So, oh wow, my machine got hung. Okay, I think this was an issue with the under-resourced machine that we're using here. Let's see. Yeah, I think it's just probably hung at this point. So let me let me just double check what the situation is. Wow. Okay, I think I should have used the bigger resource. Okay, so I can actually quickly create that. So let's go to Amazon. Yeah, sorry about this, editor. yeah, sorry, I'm just redoing some of these things just so that we don't face this issue. Should take a minute to quickly set this up. Okay, so I do have access to it. I'm just wondering if this is continuing to work or no. Okay, so what I'll do is, as usual, I'm just gonna use my local host Jupyter instance to quickly do this. Okay, so but just think of it as me doing it from the EC2 machine, but it's just basically I'm gonna just use a terminal. So let me start a terminal. So what I'm going to do is SSH into that machine. So it just happens I just spun up this machine, right? So I SSH'd, okay, I'm not in the right directory. Let me go to code directory, SSH into that machine. So this is the machine. Okay, there's just a new machine that I just quickly spun up. So what I wanted to do was, I'm not gonna worry too much about Conda environments for this, just because I'm a little bit short on time. So I'll just install we don't need the Jupyter interface for this, this beefy machine. So I'm just gonna just install Conda so that we can run the Flask app and then also package it into an image. Okay, so okay, so now we have, I'm not going to create a separate environment. So what we'll do is now git clone. MLOps code examples. And then let's go to Flask examples. Okay, so what I'll also do is quickly copy the files. That I had required. So on the models, recommendation model to this folder. Okay, I just copied. I'm just going to show you what I copied. So movie lens. Okay, so what I did is copy the movies file and the model file. Okay, so what do I have here? Oh, I just put it here. Okay. Um, okay, so this had a bunch of Flask files. So let me actually make it for Docker just as before, and move the Flask recommendation example into for Docker. Also move movies into for Docker, and also move recommendation model into for Docker. Okay, that's great. So now what we have is, oh, by the way, there are a couple of requirements that are still not installed, right? There are a bunch of requirements for the Flask file itself, which are not installed. So, but that's fine. Let's actually, so let's install Docker first, which is, we just installed it previously. Let's see if this is actually, wow, this is stuck. Great. Okay, so we installed Docker, and if you look at the, so we haven't, okay, by the way, this file is not the same file in the new machine, but what do we need here is we need to install Flask. We also need Torch, we need Pandas, and we need Surprise. Okay, so those are the things that we'll need to install. So let's install once this thing is set up. Conda, I can just install Pandas, Flask, scikit, Surprise, and Torch, right? So Torch will install using Conda. Okay, there is some issue. It looks like it needs Python 3.8. That's not good. Okay, so I do have to create Conda, create -n, py 3.8, and Python is equal to 3.8. Okay, let's install this. So I'm just creating an environment because it seems like Surprise requires that. So let's actually Conda activate Python 3.8 environment. And now let's just run the previous thing. I hope it works. Nope. Oh, GCC failed. Unable to execute GCC. Wow. Okay. So GCC is a compiler for C and and C++ as well. Sorry about a couple of detours. I thought the machine would have enough power to at least run a Docker, create a Docker image, but it looks like the machine that I had previously did not. Okay, so once we install Surprise, we just have to install Torch, and we should have everything for running the Flask app. And now I need to also define the Docker file. I'll do that in a second. Actually, we can open one more terminal maybe. what's the situation here? Okay, so let's also install, as I said, Torch. I apologize if I'm going, sorry, this is not correct. If I'm going a little bit fast, but I just wanted to get a bigger machine. Okay, actually, I guess everybody's silent, but any questions at this point of what I'm trying to do as a real-time recovery from the previous? So we just got hung up in trying to run the Flask service. Okay, so I just wanted to not have that issue.
Yeah, while that installation is going on, let me ask you, so you ran Docker as a background command, right?
When I wanted to run a specific image called getting started, I wanted to run it in the background, the container, because it's basically a web server. It's just serving those HTML files. You saw this. This is the HTML files. So to run this, I just ran that image, the container, basically in background. So that's -d just means run it as a daemon, or basically run it in the background.
Oh, okay.
Yeah.
So once you install Docker, right, it is available as a daemon anyway, right? It doesn't
So
start
there's
the
a Docker
daemon.
client, there's a Docker server. That's a
Okay.
daemon anyway. Yeah. But our container also has to be a daemon, as in
Oh,
like something which is not running in the foreground, but is running in the background as a server.
okay, got it.
Yeah. So, okay, so we have these 3 files. I think what we also need to do is edit Flask, this file, to not look for files somewhere else. I mean, we could have created all these directories and stuff, but I am not // I will not do that right now. So we'll just use the local files that we have. And that's about it. Okay. Oh, okay, those extra files. Copy from 2 layers up, maybe. More examples, recommend, star. So I'm just copying these extra files that were needed. I think I mentioned this earlier as well. Expected 88. Okay, so wow, there's so many errors. So this is exactly the issue, and the whole point of this course was to have reproducible environments, but it looks like that's a issue. But okay, let's not worry about running the Flask thing right now. So let me I mean, let's just try to create an image. So let's see if I have access to the older machine. Okay, even the newer machine would work. So let's not worry about running this. Okay, so we have the required files, the pre-trained model. So what this recommendation service does is, as you might have seen from before, right, from the notebook, from the script file, it just reads the model file, reads the extra metadata, and just give me a user ID for which I'll use the model file to make a bunch of recommended items, recommended movies, and I'll just return it back. Okay, that's what the service is doing. So, so what we want to do is create a Docker file for this. Let's create that. Let me see if I have a Docker file handy. torch-based one. I think I have it somewhere. I'm trying to find it. Five. Yeah. So sorry, it was just literally in the notes in that section. But me come back to, yeah. So the Docker file is going to be as follows. Okay, and maybe I'll edit it as needed. Shift insert. Yeah. So what I'm going to do, so again, we have seen a Docker file in the last session. I'm just going to kind of recap. So we're just starting from a base image, and this to keep it simple, to keep it easy for us, I just started at the base image, which already has Conda installed. Okay, and that makes it easy for us to do a couple of things, which is you don't have to reinstall Conda. And with Conda, we can directly install Torch in the way we have done it before. Okay, so we have Conda. I'm installing Flask and Pandas. I think Pandas will also install NumPy, I think, as a dependency. So, and then we're installing Scikit Surprise through Conda. We could have also installed pip install Conda as well. And then instead of these copy files, I'm just gonna, and we saw this idea last time, copy everything from the local directory to the remote directory. And what is the name of the file? It's Flask recommend. Oh, sorry, I don't recollect the, yeah, it's called Flask recommendation service. Okay, Flask recommendation service, and that's it. So this guy should should run on the usual port, port 5000, because we didn't change the port, but that's it. So basically, a Docker file is as simple as this. So start from some base image and add some extra things that are needed for your file to run. Copy all the files that are needed for you, and then start start with this. Okay, command. You could also write command instead of entry point, but it's the same idea. So that's right. And then now on this machine, this is supposed to be a beefier machine, but if I do sudo docker images, you can see that there are no images. So now what we'll do is sudo docker will call build instead of run. Remember, run is if you already have an image, run the image into a create a container from that image. We're going to do build, and build, since we're building, we will also give a tag. Okay, and the tag is there a specific tag that I was mentioned in the notes? Let's see. Yeah, it's called prediction underscore service. And then dot just means find the Docker file from the current folder. So let's press enter. And there were only 4 kind of lines in there. So it's doing each of the steps in order. So it's getting that image from Docker Hub, okay, hub.docker.com, sorry. And then it's running this installation, okay, adding basically a bunch of layers, and then the usual thing. So to install, I guess, Flask and Pandas, and then PyTorch as well. So these are the commands being executed. Okay, so we are still in the stage of creating the content, creating the image from which we can run the container. Oh wow, no space left on device. Wow. Sorry, this is. Did we take a bad device or something? Sorry, bad. Okay, so it looks like where is using 82% of the root folder, and everything else is yep, everything else is used up. So okay, this is not a good idea. I need to get even a bigger image, bigger machine. So okay, so what I'll do is show this Docker build locally, and yeah. So let's actually create another. Sorry, this is like the third time I'm doing this. So let's go back to um, so I'll just have the same files. Apologize for, again, significant delay here. Um, I'm just copying the same files that I just mentioned earlier. I mean, which you've seen like a couple of times already. So okay, so it's exactly the same files, a Flask and all that. So what I'll do next is do the same Docker execution. So before I do that, let me quickly edit that Flask file so that it looks at the right files. Okay, so sudo. Oh, okay, I did not create the Docker file. Okay, vim Docker file, and okay, that actually let's copy the Docker file from here. Oh, I can't copy it. Okay, looks like it works. So let's do that. Okay, sudo docker build -tag prediction service and dot. Sorry, I'm just running it again on my local machine, which should not have been the case, but maybe we'll take a little bit of a during the break. I'll change the machine so that it has all the right resources. So okay, in the meantime, let me go back to our notes. Yeah, So as I was saying earlier, a few, I guess now half an hour ago, uh, what we are going to do is try to put it in a separate, in a personal, I guess, or a private repository that's enabled by Elastic Container Registry, and then deploy it on not on a single machine. So we can always run Docker run, and we can run it from any image, run a container from any image, but we'll run it on ECS. Okay, and what ECS fetches us, as just a recap, is it makes us agnostic to the underlying resources being used. So it could be some EC2 machine. Even if the machine fails, ECS has the capability of restarting another machine and getting your container back on. Okay, so it also enables fault tolerances and things like that. So um, so Elastic Container Registry is where, as I said, we will send the image. So to get there, let's see what the situation is. It's still installing. So to get there, let's go back here. Elastic Container Registry is what we want. Yeah. So yeah. So this is basically the basic screen. So let's get started, and we can create a repository, and this repository is where we'll dump our image. Okay. So and we'll push our image. So let's create a private repository. Let's give a name. So what's the name in the notes? I just don't want to deviate too much here. It's called recommendations. Recommendations. Okay, and that's about it. So we don't need any extra stuff at the moment. So create repository. It's basically very similar to S3's bucket, right? You created a location where you can dump your image. Okay, so one nice thing is it actually tells you what commands to run next. So let me see. Yeah. So this is the, okay, so there are a few things here. So there's some name and things like that. So if you click this, yeah, so you can see it says successfully created repository recommendations. And then if you click on the top, so there's a green bar here, click on the top, right, you'll see view push command. So if you click on that, there'll be, it actually gives you, hey, if you have a local repository, then what do you need to do? So it also gives you commands for Windows as well as Linux. Anyway, we are going to try to push it from a Linux machine. So it says first try to log in to AWS, okay, and that requires some command line um, utility. The utility is called AWS itself, okay, and then this, and we are already trying to do this. Docker build tag instead of recommendations, we're just calling it prediction underscore service. Okay, after the let's say it gets built, we just have to do this command tag whatever was the name latest build of that image with this specific remote repository name. Okay, so for you it'll be a slightly different string, but you just have to run these commands. Okay, you don't really have to even parse what these commands explicitly mean. And then the last command is where you push. Okay, you use literally the Docker CLI utility to push to the AWS location. Okay, how is all this happening is because we are using we have let Docker login use the AWS's some sort of credentials, not the full AWS account's credentials, but just some sort of a role. Okay, and I'm going to talk about that in a second. So you can see this thing got built. So if I do clear, actually on my local machine there may be other images, but let's anyway sudo docker images. So there are lots of images, but the image that we care about is this. It's a prediction service that we just built. Okay, so this is the one we want to send to AWS. I don't think I have AWS CLI. Oh, I do actually have it. So, okay, so how, so, okay, so we have the AWS CLI, and now we will try to execute those commands. So let's see. Yeah, so what we need to do next is go back to, okay, so these are the commands we need to run. We can actually access this. Actually, maybe we should access it some right now. Let me actually copy these. Um, we don't need the build command. We just need the tagging command. And then the push command. So I'm just copying this because I want to go to a different AWS service. Actually, I could have opened another tab, but basically we want to go to IAM. Okay, so IAM just stands for Identity and Access Management. So we just need to touch three different services. Okay, overall, ECR, which is the place where we'll dump our image. ECS, which is the container service, which lets us run this container in a fault tolerant, in a scalable way, and all that stuff. And the third thing is identity and access management, um, which is a overall, it's specific to your full AWS account. It lets you create programmatic users. Okay, so in particular, programmatic users, I mean, instead of logging into the AWS console the way we did it through the browser, you will get what are called a secret key and an access key. Using that, command line tools like Docker can use those credentials to be able to access only restricted parts of your AWS services that you can use. For example, if I want Docker to just use access to just the ECR so that it can push the local image, then I want to use a programmatic user. I'm going to create a user basically with some, basically it's going to be some sort of a user and password that Docker can use to push to ECR. Okay. So I already have some users and groups. Let's ignore them. So let me add a user. Let's see. Yeah, let me add a user. It's going to be what users are not there. Okay, let me give a name, Flask user, or maybe Docker user, let's say. Docker user. Access type is programmatic access. And next, okay, so what we did is, hey, this person is not a real human. So it has to be some sort of an access key through which programs can access my AWS resources. And then we need to attach some existing policies. Okay, so we will attach a particular policy called policy related to ECR. So container, maybe let's search for container. Yeah, EC2 container registry full access. Okay, so let's actually enable this. I am not sure if we need S3 access. Okay, let's just enable this. Sorry. Container. Okay, we have enabled this. Other ones, I don't know. I don't think we need them. Okay, let's actually just do next. And here you can add extra information if you want. And I'm going to do next here. And then it say, hey, here's the user. This person can programmatically, I guess, user can programmatically access things with an access key. And some access thing is not set. I'm just giving the least amount of not really least amount of control. I'm actually giving full access to ECR, but other than that, I haven't, this programmatic user cannot touch any other parts of AWS. Okay, so let's create a user. Okay, now what you'll see is this is only showing partial information, but basically so you will get two things: access key and a secret key, and these are the two things that you can use for programmatic access to ECS, sorry, ECR. So I'm just going to download it. Actually, I can just copy. let me quickly stop sharing and okay, I just copied those two. And what does it say? Okay, and that's it, close. Now I have this Docker user, and this person has Amazon EC2 container registry full access. Okay, so now what we'll do is use AWS CLI to be able to log in using Docker. So let's do that. Um, Okay, so let's actually configure AWS CLI. So that requires a couple of steps. We'll just follow the instructions here. Okay, so it says, how do I configure AWS CLI? So actually, you don't need all this complicated stuff. Let's say using the AWS CLI. So there's a command called AWS configure that you can use. So let me just show that to you. Let me go back here. Configuration basics. So it says, hey, quick configuration with AWS configure, and that's what we're going to do. And what we got from previously through the browser is AWS access key and the secret key. Okay, those are the two strings that we have, and based on that we can configure. So we just need to install AWS CLI first of all. How do we install it? I will, there's a link here. I think folks can see it yourself. I'm gonna skip that right now. But maybe I can talk about it in a second. So once you install AWS CLI, it's just a program very similar to Docker. Once you install it, this is how you would configure those two strings that I got. Actually, where is this? Yeah, the two strings, I had it here before I moved on. Those two strings, you can just type AWS configure in your command line, and then give those two strings. Okay, string 1, string 2, and what's your default region and default output format. These are just extra pieces of information, but basically two key things are these two. Okay, with that, AWS knows how to access some resources from your local command line. Okay, this local command line, by the way, doesn't have a local machine. It can be that EC2 machine that we've been always using. And once you have this, we can just run those commands that we saw for Docker. Okay, so let me just do this. I'm going to configure, and then actually, okay. I'm just going to configure, as I said, I'm just going to execute those AWS configure command and give the access key and the secret key. Okay. So, okay. So if I had this user had S3 access, then I could do S3 LS. Okay. So there are many options like that. So let's not worry about it. So Let's come back here. AWS. Let's do help to see if there are some commands which I can show to. So all these is, you can see a lot of names here: Cloud9, CloudTrail, CloudWatch, and you'll also see ECR. Maybe I should do AWS ECR LS2. Sorry, AWS ECR LS. Okay, that's not the right command. List images. Actually, we don't have any images, so let's try list images. Okay, minus repository name. Okay, list images minus repository name is recommendations. Okay, I have to specify a region. Oh my god. So created this repository. Let's actually go back here. It's an US East -2. Okay, so that's the region. So let's type minus. Okay, actually, some access key and a set secret key I've already given. So US East 2. I guess that's the default region I want to pick. Okay, default output format JSON, let's say. Okay, so now I asked for what images are available in this repository called recommendations, and we know that there is no image there. Clearly, we have to put in something over there. So right now, as you can see, it says, hey, there's no images, right? Okay, so what we're going to do now is execute those 3 commands. So those 3 commands that we saw when we created this repository, right? So actually, we can still access those commands. Let's click here. View push commands at the top right. You still have those commands. So when you click on that, it'll say, hey, on Mac, on Windows, how do you push the put commands there? So sorry, push an image to this repository. So this is the command I'm going to copy and run it here. So let me do that. I'm wondering if sudo is going to cause some issue, but let's see. On Mac, you don't need the, by the way, so on Mac, you don't need the extra sudo stuff in front of Docker. It says here, your password will be stored and encrypted and all that, and then login succeeded. Okay, this is a step 1. Then what we need to do is tag our repository. So tag the image that we created with this remote repository's name. Okay, it's remote repository's name is called the second thing. It's a huge name here, aws.com, Amazon AWS.com / recommendations latest. Okay, that's fine. Some name is given there. So what we're going to do is give tag the image that we created, prediction underscores, I don't remember now. Is it prediction underscore service maybe? Okay, let's, we can't run this because on Linux, you need to use sudo. Okay, so now if I do sudo docker images, we should see prediction service, the thing that we created. It'll have some image ID, and same image ID will be followed for the new repository name that we have created. So all we've done is log into AWS through Docker, step 1. Step 2, we have created a specific image name that is needed. Okay, this generic image name like, hey, my image or something will not work. You need to have this extra string here, which is specific to your account. Okay, instead of this 27 something number, you may have something else. Instead of this region, you may have a different region. But anyway, we got a new tag. Okay, its underlying image is the same. It's not like the data is copied. The data is actually, the image size is actually 2 gigs. So we created this image. Now we just have to push it. Okay, so the push command is just docker push the image name. Okay, so that we'll do here with the extra sudo as well. Okay, so it says, hey, I'm pushing all this 2 GB of image files, and you'll see there's multiple. I guess there's some parallel pushing going on. So okay, so once it pushes, what you'll see is we'll see an entry here that hey, at this recommendation, there's no image at the moment, but you can there's going to be one image here. So at this time, let me quickly check if there's any questions or comments. We had like a 15-20 minute break or delay because of underpowered machines, but more of that, if there are any questions, I can take it now.
Okay, can you go back to your local machine,
Yeah.
please?
Yeah.
Okay,
Yeah.
so this AWS, I don't know what the name that was used,
Yeah,
the toolkit
the just
or
like
some.
Docker, AWS is also just the name of a command line utility. Okay, how do we
Okay,
get that?
command
You can
line
just
utility, yeah, CLI, command
yeah,
line interface. Yeah, okay, got it.
yeah, it's a CLI. And how do you get it? Actually, the installation is very simple. Sudo apt install AWS. Sorry, um, yeah, sudo apt install AWS CLI. In fact, it gives you. Let me tell
Okay,
you the exact command. Um,
okay, let me write it
yeah,
down.
so the exact command that you want to use is this. Okay, so just like we install Docker here, AWS
Okay,
CLI is like this. So let me paste it here in the chat in case folks are wondering. This is a step that I skipped earlier because I already had it locally.
no, my
But on the
question
remote
was
machine, we
not,
have to just run this. Yeah.
yeah, sorry, no, sorry. My question was not about this one.
Mm-hmm.
Um, so imagine it, I don't know how much time I could ask this question, but imagine a scenario where
Mm-hmm.
typically, right, the dev environment and testing environment, production environment will all be AWS. Nobody's going to build test environment in Azure and production in
Yeah.
AWS and all that.
Yeah.
So the step that we have outlined here in this process, right?
Yeah. Yeah.
This should probably look exactly the same when we go to AWS to AWS to AWS from dev to test to production. Is that a
Yes.
fair way to understand it?
Yes, yes, yes. So whatever you've done is the minimum requirement wherever you are. If you're completely within AWS, like your dev machines and production machines, everything is inside AWS.
Okay.
Still you need to do the same things that what we did.
Okay. So
Inside AWS, there's an ECR. Wherever dev machine I have, I need to push that thing to ECR so that it can be used for use with other services.
okay.
It doesn't have to be ECR. Okay, if you have a public image that you just want to run, like from Docker Hub or something, you don't need ECR stuff. But ECR stuff is when you have your model, right, potentially a proprietary model, and you want to have expose it to certain people or something like that. Then ECR is the way to your image. You don't want to give it away to everybody, right?
Right.
Yeah.
Okay. So that was one. Now the next question is,
Mm-hmm.
so let's say I have one EC2 instance. I'm
Mm-hmm.
not referring to your local machine, by the way. I'm
Yes,
referring
yes.
to one EC2 instance. And in
Yes.
this EC2 instance, let's say I have 3 Conda
Yeah.
environments.
Yeah.
Now, 3 different Conda environments does translates to 3 different operating environments, right? Because I can install and start different services in these 3 different environments in parallel.
Yes. 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 Yeah.
Through the screen command that you
Yes.
have, and a
Yes.
combination of all that, I can make this look like 3 different environments.
Yes.
So the idea in that mechanism would be, does people use it in that manner?
So Conda environments actually they don't run multiple services on different environments. Yeah, but that's the way to do it. Yeah, people do.
Okay.
But the way you have to think of environments as also like whenever you create an environment, if you're done with it, you can dump whatever was the configuration of the environment into a file. Okay, it's very similar to requirements.txt. We saw requirements.txt where you can write, hey, what all packages were used or were installed using pip, for example.
Yes.
So you can get requirements.txt by just saying pip freeze, and then you'll get the
Okay.
requirements.txt. Similarly, Conda environment, if you do it on a project and then you want to come back 6 months later or give it to a teammate, what you do is you can do Conda export the environment, whatever was configured in that environment. Okay, it'll create a simple text file, some YAML file, and then the other person can do Conda create from this particular text file. Okay, so they don't have to redo anything manually. They'll get the exact environment. Okay, so this portability is there. But in terms of
Okay.
like parallelly running let's say Python 2.7 based some program, and then Python 3.6 based some program, and then Python 3.9 some program, and let's say they're all web services, yeah, you can do that. Yeah.
Okay. So under that scenario, right? So because I'm trying to think online here. So
Yeah.
So let's say we create a conda environment that's called dev 38 or something like that, and they test 38 or something like that. So I have two different environments.
Yeah.
No, now I activate dev 38,
Yeah.
and then I create a Docker file.
Yeah.
I could go to test 38,
Yeah.
and I could run that container.
Yeah.
It will the OS, then the conda environment, then the Docker.
No, so Docker is kind of orthogonal to the conda environments.
Oh, okay, all right.
So Docker will have its own, like when the container runs, Docker will say, hey, these are the packages that you can see. And that is completely specified in that Docker file that I
Okay.
think I
No,
shared
I
somewhere.
can
Yeah.
imagine that's what we are just running right here.
Yeah.
Whatever we said in the Docker file, that's all that's
Yeah.
happening, right?
So
Okay.
this Docker, the image that we are uploading to AWS, that thing, it can run in any environment. Okay, it doesn't have, you don't even have to have Python on that machine. Okay, you just need Docker on that machine.
Okay.
Because everything that the program needs, in this case, the Flask recommend thing, everything that it needs is already there in the image.
Okay.
Actually,
So
one crucial thing I kind of should check, of course, it's not an issue still, is that when I created that image, I should have run that image locally to see whether it has it has everything. Okay, this otherwise I've uploaded like 2 gigs of data into AWS, and then I'm checking that the Docker file doesn't, the image doesn't work, something like that. Anyway,
well,
that's
I
beside
mean,
the
but that is only to validate that the image is not corrupted ultimately, right?
No, the
That's
configurations that I have included all the files and so on. Like I installed everything that is needed for the script.
okay.
Yeah, I
That's
could have just
interesting.
done Docker run before I started uploading stuff. But anyway,
Okay, in a different folder, is that the
no,
idea?
I have this image. I'm just saying in like, for example, I can just create. I have another terminal, right? So I can open
Oh,
another
okay, all
terminal,
right.
just run the thing. I mean, it doesn't have to be in any folder, but sudo docker minus, again, port forwarding. I want to do minus dp. Let's say 5,000 to 5,000, and then prediction. Let's go service. Sorry, because this is sudo and this is my local machine. Okay, I forgot run extra thing. Okay, so it started a container, and if I do docker ps, so I'm just saying that we should have checked this. Oh wow. Oh yeah, there was an error on this. Okay, let me just do a ps minus a. So it exited because of some reason. Okay, I will check this and let you know. So I should have checked this before uploading the image. Yeah. Anyway,
Okay.
I think we are losing time on a lot of tangential things, but let's take a break. Maybe this time only, let's resume at 7:55. I don't want to lose too much more time. Okay, so 7:55, let's regroup. And if George, if you still have questions, can you wait till the end of the
Yeah,
class?
no problem. I have no problem with that. I just wanted to understand how the process works. That is,
Yeah.
I mean, it's taking a little while to understand the pieces. That's all. Pardon
Yeah.
me for.
No. I mean, it's fine. We are not trying to rush through any course material. There's an exploratory survey course basically into different technologies. So we'll certainly pick up, maybe we can take the question right after the break. We'll resume at 7:55, so folks, they can take a break for now.
Okay, thank you, sir.
Yeah, yeah. Okay, so what I'm going to do is lab. Yeah. Yeah. So it looks like I did have some issue. Yeah. So the issue is basically that I don't have sklearn, which I forgot to include in the in the Docker file. So let me try to include that and then see. So I'm just, I'm going to spend another minute on this. If and you'll see, and I want to also want to point out something very quick. What I did is slightly change the Docker file to include um, um, to include uh, scikit-learn, right? It says here scikit-learn is not available. So what I'm going to do now is again rebuild it. Okay, so docker build -t prediction service.
Hi, Professor. Sorry, I can't see
Yeah.
what you're typing.
Oh, is it too far down in the bottom?
Yeah, I think so. Yeah.
Okay, let's try to. How do I get? Okay, let me. Let me actually and execute it anyway, and then I'll just show it again. So basically, what I did was I'm in this folder. Okay, so I did this command before all this AWS stuff. I did this command. Okay, I literally redid this command. And what changed from before, from when I executed before to now, is that I added an extra scikit-learn in the Docker file. Okay, so how do I? The way I can show this is if I do less a Docker file, you can see that I add an extra scikit-learn here. And actually, it could be, I should have looked up what all dependencies are there in all the files here. So what I did, the way I wrote the Docker file earlier was just I looked at, hey, what all am I including in the recommendation service.py? Okay, but since I'm also using these other two files, and those files may have their own imports that they're doing, I forgot to install them, and therefore my image was not working. And so I'm installing scikit-learn. So actually, let me look at what all are there in the recommend PyTorch. Train requires torch. See, this dependency I forgot, and so it didn't work. NumPy, I believe it installs by itself. Otherwise, I could explicitly also state that NumPy is needed. Similarly, the other inf doesn't require anything else other than what we've already done. So surprise, NumPy, torch, pandas. Okay, pandas, I believe we are installing anyway in the Docker file, and also pprint. I don't know if we need to install pprint, but yeah. So those are the issues that I didn't see earlier, and because of which our image, when I was trying to run it as a container, it was failing. Let's see. So if I run this guy, no, there is still an error. Oh, okay, this is some error that I think is beyond the scope of this particular thing, which is about some data set import. So, okay, so let's not worry about it. Too many errors, I think, with trying to create an image with the prediction, with the recommendation model. If not recommendation model, we actually have many other choices. I think I just chose the wrong example. We have, if we go back to our notebooks, we could have created the Docker file from any of these. Docker file as in like an image from any of these models in the Flask examples. In the Flask examples, you'll see that we have 3 prediction models, right? A recommendation service, and that's what I was trying to get to. We have a simple regression service, which could have just illustrated, hey, how do you get that thing wrapped up in a image? I mean, we can do that in now, but I don't want to spend time on that right now because I want to get to pipelines a little bit today. And there's also another model, which is the ImageNet service model. Okay, so these are the 3 models that we already have. ImageNet, we are not training it a priori. It's a pre-existing model from the internet. We're just downloading it and using it to make predictions. For these two, the recommendation service and the simple regression service, we have a way to train the model. And how do you see that? If you go to model examples, you'll see there are 2 files, one for recommendation and 2 for recommendation and 2 for simple regression. Okay, one is called training, which creates the model file and writes it to local directory or something like that. And the other file called inference, which reads that model file and shows some example I guess, predictions. Okay, so we'll fix this Docker stuff later about why surprise is actually causing an error. But what we want to do, what I'm going to do is pause our effort into getting ECR and therefore ECS working. Maybe I can show it early next class about, we've already uploaded, by the way, we did the ECR part mechanically. You can see there's no image here. And if I refresh, certainly there's going to be an image because we just uploaded it. It's just that uploaded image, I can deploy it using ECS, but it's not going to work. And I just told you why it's not going to work. I forgot to include some scikit-learn and some extra things. Okay. But I hope that's clear. So I will pick this up most likely in next class, just to show you with a proper working image how the recommendation model will work. I just if I had chosen some other model, one of the other models, then we might have been in a much better shape. Okay. But what I want to do now is switch over to so that concludes that Docker hosted and Docker managed. Okay, managed. The point was if we have a working image in ECR, then there's a sibling service called container service, Amazon container service, which has a very simple GUI way to set up and get your container running. And the difference, just to summarize, is that when you get the container running in a hosted version, you need to know what the underlying machine is, like an EC2 machine or your local machine or something like that. Whereas if you do ECS, the sibling service, then that takes care of the underlying EC2 resources. It automatically spins up EC2 resources that are required for your container to run. And maybe if EC2 instance suddenly terminates because of some failure, it'll immediately restart another EC2 machine and get your container again deployed so that everything is running smoothly. Okay, so that's the, I guess, advantage of having a managed service. So we'll do that. So that concludes, that wraps up that section, right? Let's go back here. On chapter 3, the chapter 3's objective was to play with Docker and then work with ECR, which is what we did today. Mechanically we are correct, but the image that I uploaded will not work. So I don't want to again spend 20 minutes on getting the right image there. And ECS is just a sibling step, as I was saying. So we'll do this potentially next week, just to just to see how the container gets deployed in a managed version. So what I'm going to do now is, instead of going to chapter 4, which is about Kubernetes, which is just a replacement for ECS. So what I was trying to show in chapter 3 was to get to ECS as a managed version for dealing with containers, right? As a managed service provided by a vendor, AWS, to deal with containers. Similarly, Kubernetes is an open source technology, and both AWS and Google Cloud provide managed Kubernetes services. Okay, it's literally called on Google side, it's called Google Kubernetes Engine. On AWS side, it's called EKS, Elastic Kubernetes Service. So anyway, so they are just replacements for Elastic Container Service. But it's a new technology, and a lot of tech companies, or not just tech companies, any company which needs a lot of services to be deployed, including prediction services, machine learning services, they use Kubernetes. So, but we'll not look at that chapter right now, and we'll talk about chapter 5. In chapter 5, there is a part which requires Kubernetes as a demonstration for demonstration purposes. So maybe we'll discuss about it at that time. So now, for the next 20 minutes, let's focus on get some intuition about ML pipelines. And this is something I thought was important because earlier in some offline discussions, some students asked about this this aspect. Okay, so I hope everybody's clear and with respect to where we're going now, and I would say at this point you can forget about Docker and all the things that we saw up to now because we're starting a new topic. So let's look at the table of contents. So what is the set of topics that we're going to cover? Today, we may just touch about the first 2 topics, which is, in general, data science workflows. How should one think about them? And then we'll look at a simple pipeline, okay? A simple workflow or a pipeline. Okay. and then we'll talk about cron and other things later. There are two things that we wanted to see in this chapter, which is scheduling using a really old utility called cron. If not that, there's a Python, very Python compatible, or basically it's probably also yeah, very Python compatible package called Airflow, which lets you do this, deal with pipelines in a nice way. And I'll tell you what pipelines are now. Okay. So um, I wanted to also quickly tell you what the goals of this part are. And GitHub doesn't, okay, it did work. So, okay, let's highlight here. Oh, not that one, sorry. Yeah, ML model pipelines. The objective is, hey, how do I manage a model building and model serving workflow? Okay, so at least you need to get a sense of managing a, so somebody's already, so first time you wrote the model training script, that's not the end of it, right? So once you write a model training script, you might have to retrain again and again, maybe every month, every 6 months, and so on. So that's about managing the model training. And there's also management of model serving, right? You may want to have an updated model serving fresher predictions next week or next month. So how do you manage these aspects of redoing things? Okay, so that's what we'll get exposed to. Second thing is how to set up automation, in the sense that if I want a model to retrain, and I know that there's a fresh data that gets dumped into a table in a database, and I just want the model to run immediately when there is fresh data, there are ways to do that. And one of the example, very, I guess, simple example actually, is using a utility called cron. Okay, cron is available predominantly, of course, on Linux machines, Linux OSs, but also on other systems. And then there's also a more elaborate, I guess, more sophisticated tool that folks use called Airflow. Okay, and so we just want to get exposed to these two ways of scheduling tasks, the scheduling parts of our machine learning modeling, as well as deployment aspects. Okay. So with that, let me actually talk about workflows. So workflows or work streams or pipelines are all about tasks. Okay, basically pipelines just mean whatever process we have, we should think about um, the process from start to end as some sort of modular blocks. Okay, modular steps. Literally, if there'll be stepwise instructions of do A, do B, and then do C, and then do D. Steps, right? So if you think about it that way, then these steps can be chained, connected in a directed fashion. Hey, step one, maybe some computer has to execute some program, and then step two, some other computer has to execute some other program, and so on. Okay, so you think of it in some sort of a directed fashion. First, step one has to finish, then step two has to start, and so on. Okay, it could be just a sequence, like step one, step two, step three, step four, or there could be some things which can happen parallelly, right? After step one, maybe step two and step three can happen parallelly. Okay, and then both their outputs are required for maybe step four. Okay, so it can be a more richer, I guess, precedence ordering between these modular steps. Okay, and although I've been talking about modular steps, what is it specifically for ML workflows, right? It's just exactly what you already know. So fetching data, pre-processing data, training a model using data, and then once you have a trained model, getting predictions from that model, and then once you have the predictions, pushing it somewhere, maybe to a database, maybe to S3, or maybe to an AWS Lambda function, which exposes to the world. Okay, so those are the tasks I mean by steps. Okay, and some desirable properties you want is ability to manage multiple pipelines. So maybe it's not just one model that your company deals with, right? Maybe there are 10 different models. One is about churn prediction, one is about recommendations, the other one is about maybe, let's say you're Netflix, and so the other one could be, hey, what is the video resolution that is more suitable for Chicago, and what is the video resolution that's more suitable for let's say Los Angeles, right? So there's a lot of things where lot of different models that may be deployed. Okay, so there will be a lot of different pipelines, a lot of different data that gets cleaned, and models get trained, and models get deployed, right? Um, you also want we also want generally the ability to run these blocks, these steps in a schedule. Okay, maybe in the morning I should clean the data, maybe in the afternoon I should train my model, maybe at night I should update my predictions for the next x hours of running, right? So, and then finally also these one desirable property we want with managing with machine learning workflows is to get exposed to whenever there is a failure event. For example, one of the blocks did not run because there are extra nans, or because the image did not get built, or image got built but could not get deployed, like we saw earlier. Those steps, if they did not happen properly, then immediately somebody else can step in and um, fix it, and the subsequent steps or blocks can wait. Okay, they can retry maybe maybe 2 hours later, maybe in 2 hours somebody else has fixed this issue with the current block, and so on. Okay, and that's where workflow or pipeline tools come into the picture. Okay, so they allow specification of this ordering. Hey, do data prep first, then train model first, and then get predictions, and then maybe serve the predictions. They ensure that dependencies are met, and that's where things like Docker already take care of dependencies. And so if you keep things modular, you can also better track dependencies. And finally, everything can be automated, right? This scheduling and rerunning of things can be automated. And there are lots of tools here. I've just listed a few, right? Airflow, MLflow. These are all different names, with a lot of names having flow there. But these are all by many tech companies that you may already be aware of. But basically, we're going to look at only one of them, maybe later, called Airflow. But it turns out that in modern times, basically, in the past few years, these tools have become very essential for those companies which have multiple teams working on multiple models, multiple iterations of models, which need to be retrained, rerun. Reports need to be generated in terms of the prediction performance again and again and again. So for all this, these tools become indispensable. Sorry. Um, our goals are going to be, hey, let's build a pipeline running in a container. And so we just saw we have been seeing containers for the past 2 sessions. So we'll also see another container build now. And then we'll look at I guess the more important parts are not about containers for this chapter. It's about getting a feel for cron, which is a single machine solution for scheduling. And then we'll also get a feel for Airflow later on. Okay. Any questions at this point? Okay. I'm just trying to monitor the chat as well in case there's some questions in chat. So yeah, so we just discussed a lot about what do I mean by pipelines informally. Formally, it's basically it's basically the whole process from end to end, from the moment measurements are made, maybe in your app, maybe in a physical setting, let's say in a factory, all the way to getting tangible outcomes from the data science workflow, right? So typical blocks that you'd see, and they themselves will have a lot of specific subtasks: extracting data, collecting data, extracting and processing it, training a model, predicting it on a specific test set, which itself can be changing over time, and saving or dumping this result somewhere. Okay, maybe serve it using a Lambda function, maybe put it in a MySQL database, those types of things. So there are two types of pipelines that I want to focus on for this, for our information. Okay, first one is called persistent model pipeline. Okay, persistent model pipeline refers to, I mean, this is just a classification of things. So persistent model pipeline refers to the situation where the model is being trained. Okay, maybe it's trained every 3 months, okay, it's decoupled. The training is decoupled from the number of times you have to make predictions. Okay, in the sense that maybe the model is getting trained every 3 months, but maybe you have to generate predictions every week. Okay, so which means every week you're getting new test data. For example, think of a um, um, like in the insurance industry, maybe a risk of default type of a model. Okay, hey, what's the risk of default of a certain contract, okay, of certain party? Then the risk of default, there's a model which can predict the risk of default. Every week there's going to be new contracts that come in for which you can predict the risk of default. But this model itself is retrained, several months later. Okay, there's basically a decoupling between making predictions and making models. In contrast to that, another slightly different slightly different pipeline or workflow is the following, which is the transient model pipeline. Okay. Here, modeling is tightly related to when you need predictions. Okay, so in the sense that um, if you want a fresh set of predictions every week, okay, in a batch way, all this is batch, by the way. I didn't emphasize the word batch in this section here. Batch means, whenever you have data, training data is always batched, and similarly, predictions are also batched, but predictions certainly can also happen in real time, one at a time. But so transient model pipeline, anyway, coming back to this, is the following idea, that the model itself is tightly coupled to predictions, which means that if I want to make predictions every week, then right before I make predictions, I'll retrain the freshest model possible. Okay, so every week when I want to get the newest predictions, I'll take the newest data, train a model, get the freshest predictions. Okay, so in this sense, the model itself is kind of an intermediate artifact. Okay, because I got the freshest data, I computed something in between, which is the freshest model, but that itself is not important to me. I just get the freshest predictions, and next week I don't need this model. Okay, next week I again get the freshest data and get the freshest predictions. So in the sense, it's the model is transient, and so that's why this is called transient model pipeline. Transient pipelines or persistent pipelines both have their pros and cons. For example, transient requires more compute resources because you're getting a model every time you want to get new predictions. Okay. At the same time, transient pipelines have this advantage that your model is the freshest model possible or the newest model possible. So the model doesn't go stale. Okay. If, for example, if you're in a consumer facing business, then consumer behaviors may change over time. Okay, maybe their interests may change according to the trends. So if you don't update your model that frequently, then maybe your predictions are going to be completely off. Okay. So that's that. I just wanted to highlight these two as the key things in this subsection. Now, we're going to focus on transient pipeline for the minimum working example that we want to build. So a transient pipeline just means that the model is built from scratch every time I want to generate predictions. Okay, and this is what we're going to do as an example. And our subtasks in this transient pipeline are as follows. And we have already done this actually just before before the break, as well as in the previous sessions. And we're going to pick up the same, model class. So we'll get the training data. So in fact, we'll use actually the recommendation example again here. So what we'll do is getting the training data, we already have used a particular class in a package called Surprise Lib to get the movie lens data. Okay. So what if, so although we don't have updated data every week or every month here, it's easy to imagine that, hey, if I had updated user movie interaction data, then a similar way to get that new data can be done. Okay, so we're not going to focus on this part. Training, we already again have seen a training, how to train a model. In particular, we have a PyTorch-based neural network-based model, but that is also not very critical. We can use any like a simpler model as well here. The model is also not very critical here. What's important, I guess, in this section is we're going to focus on two of the other tasks, which is use the model to make predictions. Okay, So this is like one of the blocks in the pipeline to get the model from somewhere. Okay, the previous block gave us a model, trained a model. The next block should read the model and get some predictions. And then there's also another block which introduces a new thing, which is this block is gonna take the predictions and dump it to an external location. In particular, we're gonna try out how to dump the predictions to a service called BigQuery. Okay, BigQuery, just think of it as an application database, very similar to a Postgres or a MySQL instance. Okay. And so we're going to focus only on these two parts: use the model for predictions and saving the predictions to an external resource. Ideally, if you really think about it, you would have 4 different scripts. Like if you think of 4 different containers or 4 different scripts, one would do data fetching, freshest data of user interactions with your movies, let's say. And then the second script would say, hey, given this user movie interaction newest data, let's train a new model. Maybe it's a matrix factorization model or PyTorch model. And then the third container or script would say, hey, let's read that dumped model from a disk and make some predictions on the users that are currently active for this week. And then finally, given those predictions, can we put it into a location where our apps or something like our browser or whatever, our code, client-side code can read those predictions and show appropriate things. Okay. Ideally, you would want to do it in, let's say, 4 different containers. We will not do that here. We'll just do a single script, although we can just break it into 2 scripts as well. And the script is written here. So let's not worry about what's going on in each function here. So there's a bunch of imports. There's one function called get model from disk. Okay, so this is the one. We're talking about this step. Use the model for predictions. Okay, so let's get the model from disk. That's one step, I guess a part of the step, and then get predictions. Okay, so get the model and get the predictions. And so here you'll see that we basically create a data frame. Okay, and then I guess the 4th step was you already have predictions, which is in the data frame, upload it to location. Okay, in this case, we're going to say let's upload it to BigQuery. And there's some hard-coded information here that you will have to change if you want to run it yourself. This information is about, again, very similar to how we did with ECR. There is some specific strings that come with, let's say, in this case, BigQuery is a service by Google. So Google specific information like, hey, what's your project ID and what's the table in which you want to dump this data to that you need to pre-specify. Similarly, again, very similar to the keys, the secret key and access key that we got with AWS, we'll also need to get a similar, I guess, programmatic user or a service user in Google's case. I'll probably illustrate this in the next session. Okay, so those are the 2 steps, and they're happening in the same script, same, I guess, single file. But you can imagine this thing happening in 2 files, right? One is get predictions and again dump the predictions to disk, and then read the predictions from disk and put it into a database. Okay, there are 2. We could have 2 different scripts. Okay, 2 different Python files, and both Python files can be in their own containers, except that they just need to be able to access the same storage, let's say some S3 or Google Cloud Storage, to be able to read and write. Okay, as long as they can do that, they could be 2 different containers. And now if you have 2 different containers, one can follow the other. So you run one, okay, and then once the first one finishes, only then you trigger the next one. Okay, so in that sense, you have this sequence of executions, and then if one of the container fails to run, the subsequent ones will keep retrying maybe every 2 hours or something like that. In the meantime, somebody gets alerted and they can go back and say, hey, why did this container not run? Fix some things and get the container to run. And once it runs manually, let's say, the subsequent containers get triggered automatically and they'll run. Okay, so I will stop here at this point because I don't want to do another command line stuff related to Google today. Any questions about pipelines? And I know this concept may be somewhat straightforward for some of you, but for some others who are relatively new, the idea of a transient pipeline or a transient batch pipeline or a yeah, or a persistent batch pipeline, it may be new. Any questions?
Professor, this is Chaitanya. I have a question. Like you mentioned for transient pipeline, the model is built from scratch every time to generate predictions. So we already have a model now for that movie lens prediction. So we
Yes.
are going to upload that to our Flask and the AWS, all that stuff. So what do you mean by it builds from scratch? We already have the model built and we are like putting it on our machine, right? Like the so I didn't get like is it just like running it and generating results, or what does it mean by building from scratch again?
So building from scratch implies that where is this? Let's go back to, yeah. Sorry, I want to just show you the code. So let's go back here. Yeah, I should bookmark this, but when I say building from scratch, I mean, let's go back to here. So they're, running this train script again and again. Okay.
Okay.
So train script is the one which builds that model, right? At the end of the day, although it's a long script, at the end of the day, it's dumping a model, right? Now, of course, if the data is the same, it's going to dump the same model, ideally, if there is not enough randomness. If there is no randomness in the way it does the gradient update and all that stuff, then it will produce the same model. Okay. But the point is, every week you may get, if you're Netflix, if every week you may get new interaction data of users. Okay. You get new interactions data, then you rerun the script, you'll get a new model. You get a new model, use the model to again regenerate new predictions for your active users, and that's the one you're gonna deploy. Yeah, that's all I mean. So if you just rerun, if you just rerun when previous blocks are producing the same thing, it's not useful. Yeah.
Okay. So it's like in the persistent model, we will already train our model and just like weekly or daily, only on the test data, like the new data, what comes in, we are just going to perform on that and just give our answers.
Yes. In persistent, you are concerned about, you don't need to update the model again and again. So think of some weather forecasting model, right? Okay. So you train the weather forecasting model. Okay, maybe that's a bad example. Let's say some stock forecasting model, something. That model may not. Once you have that model, okay, some weights of that's an SVM or a random forest or whatever. Let's say it's once you train that model, you can keep making predictions for the next 10 days. With the same model. Okay, it's not like maybe there's new data that's coming in, but you don't have to retrain the model. For some situations, this is completely fine. You don't have to retrain the model every time you get one new data point. Doesn't mean that you have to immediately retrain the model, right? Yeah. So in fact, a lot of people do it this way, which is persistent, where because it really saves them a lot of compute resources as well. So you don't have to keep spending keep spinning up machines or keep retraining, especially deep learning models. You definitely don't do this. So yeah. And this makes sense for folks who don't really care about the model itself. They just want the freshest data and the freshest predictions. Okay. They know roughly that intermediately there's going to be model built, but that is kind of not the end result in itself.
Yeah. Thanks.
Okay, so we had a lot of hiccups in this session, but I think we are almost out of time. So if there are any questions, stay back and I can debrief more about what we saw today, as well as in the earlier sessions. And otherwise, have a good weekend, and I'll see you guys next week.
Thank you, Professor.
I wanted to talk to you about the project, Professor, personally. So if you stay back after the class.
Yeah. So we are on now. I'm just stopping the recording.